you have a tab where there are multiple tabs, and you want to fade between those tabs, you can use something like animated crossfade, where you can set a value that, okay, if it is tab 1, fade to tab 1. If it is tab 2, fade to tab 2. You have many more. You can look that up. All right, so what if I cannot find an appropriate animated widget? I would like Eric to talk to us about that.
Okay, so thank you so much, Tomiwa. We actually realized that in implicit animations, it's pretty simple or straightforward. You're just setting state, and when we set state, of course, we are going to have a rebuild. So when it's rebuilding, it changes the value or interpolates it from the old value to the new value. Now, for example, we fall into some pitfalls. We've spoken of animated container and all of the animated fools. At one point, say you want to translate an item or move it from one point to another. I don't think there's any animated translate, which is much more difficult. In that case, a simple a way to go about that would be to use animation twin animation builder. This is one of the most powerful widget I use. I think it's between implicit and explicit. It's just like lying in the middle of it. Now with twin animation builder, you define the twin, you have the duration, you have the curve on n, you have a child property. The child will obviously be the widget you're animating. Now, what is so interesting about this is with the twin animation builder, you have an on n. I think basically all of the animation controller or full have the on n, which could be used to do some interesting things. You can just use it maybe at the end of the animation, you might want to revert. So I think twin animation builder is a very powerful widget. This is your go-to because it exposes the value which is animated, and you can use this value in any other widget which is not an animated full. Yeah, and I think we had an example for that.
Before the example, I will also like to add that, as the name implies, because some people might be like, what is twin? You have twin animation builder. So as Eric said before, he explained what twin is for. So twin animation builder, just as the name implies, you have to set twin as part of the property, and you have to set duration. So one thing about implicit animation is that any implicit animation widget you want to use, you have to set duration. Duration is one of the required property of implicit animation. So the example.
Yeah, this is a typical example of where I might want to use twin animation builder. If you can see properly, we have a transform widget in the twin animation builder. In the builder, you have a context, value, and child. So that value is actually the animated value, right? So if your twin was doubles, so you are leaving from 0. In this case, we have 0 to 0.02. We have a property we were animating there is forward. So in this case, you notice that the twin leaves from 0 to 0.2. Then down here where I have the transform widget, I now have some properties I'm modifying there, like in the rotate, I'm having a mat.py multiply it by the value. Now this value is actually the interpolated value. So if you had 0 to 0.2, value is going to change from 0 to 0.01 to 0.0018 right up to 0.02 as we have in this case. And of course you have that duration. So in this case now, it is going to help so in our case, all right. So in the transform, we are going to now have the interpolation. The rotate x now is going to actually change from 0 to 0.02, and it's going to translate smoothly, not abruptly, because the twin animation builder sort this out for us. An interesting thing there is the key. So the key actually is going to help you to redefine when the twin animation builder is going to rebuild. So if you're changing the twin, the key, like I have a value key with is forward, its forward should be a boolean. So we are changing it forward to true and false. So when it changes to true and false, the twin animation builder is going to rebuild, and when it rebuilds, you're going to have the new value interpolating from 0 to 0.2 or vice versa. Yeah. Yeah. I think this is a cool example of what happens. So we have, this is the translate, right? We had the translate, which moves it like a pseudo 3D effect. Now you have to set in some properties there in the translate, of course. Then you can actually notice that whenever I click, for example, it's going to transit, right, the value, and we are rotating the x direction. That's very important too. I think this is about twin animation builder, unless you have something to add. Explicit. Okay, while they're sorting out our sound thing, explicit animation. Typically, what if you want to have a final control of your animation? For example, say we had the previous example where you were changing the color from red to blue, right? Was it from red to blue? Yeah. Now, what if you want to stop that red in the middle? It's going to translate from red to blue. What if you wanted to stop the animation when it's partway red and blue? It becomes very difficult to handle that with animated full widgets. So to have a final control over the animation, we are going to use explicit animations. And explicit animations uses the controller. Yeah, I already spoke about this.
Just want to test it.
So full control is customizable. We have ability to do complex things, right? You can do a lot of things with explicit animations. Let's go ahead. Yeah, and in addition to this, you can now extend the transitions, right? The full transitions. So if you had scale transition or size transition, you can now use the animation property in one of these widgets, and it's going to do the trick for you. The important thing is you now have a controller which exposes a lot of parameters to you. You can start, you can stop, you can reset, and do many things with it. And this is a typical example where you might want to use an animation, an explicit animation. You want to talk about that?
All right. As you can see in the example, we have a different animation that is working here. So in the example, if you notice, when new number comes out, it's scaled out. And when you matches as well, something happens. So this is part of the code base where something like that things that fade out or scale out. This is a typical example of like where it is happening. So here, if you want to work with implicit animation, number one thing is you have to extend single ticker provider state mixing, or you extend ticker provider state mixing. Maybe you are using multiple animation controllers.
Yes.
So yeah, the class is a mixing, so that's why we use weight. And we have declaration of animation, controller, offset, and all. And as you can see in our initialization function, we have animation controller where we initialize the animation controller and telling the animation controller that we want our current class to be the animation controller. And we also specify duration. If you look at what we have been talking so far, you see that duration is one of the key points of animation. Here, I set the durations to 100 milliseconds. We have offset animation where we define the current offset to the end offset. And this also works with multiple widgets. So we want to make sure that when new widget is added, we want to animate that widget. So that's why we do something like did update widget here. And this is what is doing the magic. Transform widgets. You have matrix dot translate where we put that offset we are animating
the animation value.
And our child. So introduce us to hero animations.
Okay. Thank you so much for the sound. Hero animations. Think of hero animations like through smooth transitions between two different screens. So if you have, for example, yeah, it's gone again.
Don't go again.
Okay, so we use it a lot when you want to do an animation that leaves from one screen to another screen. For example, you are leaving a catalog page. You can use it with scale transition. You can use it with whatever transition, scale transitions is going to do the trick for you. And this is a typical example of what Hero does. So I guess in this case, Tomiyawa and I are Superman flying between two screens. And you can clearly see that here. Now, what makes Hero animations more interesting, which I like a lot, is page transitions. Why are page and transitions very essential for Hero? Now, you notice that by default, Flutter implements the material implements scrolling when you are moving to a different screen. A lot of people don't see this to be, the view about it is not too pleasing, right? What if you don't want to slide, right? For example, I typically just want to fade in the next screen while doing the Hero transition. It makes it so cool. So page transitions now will help you to achieve that. Page transition is just simple, the animation between a previous screen and the next screen when you are popping or when you are pushing to a new screen. And of course, iOS has its own implementation as well as Android. Now we have, you can build a custom page transition, your own page transition. And a typical code is going to look like extending or using the page route builder, which exposes the page builder. Now in this page builder, you now have the animation object, which can be used, right, with any of the full transitions, right? In this case, I'm using slide transition. So when I'm navigating between the two screens, I'm going to have a slide effect. You can replace that with fade transition. And once you're navigating, it's going to fade into the next screen. Yeah. And of course, these are some, you have fade, slide, scale, rotate, size, and others. This has been interesting. These are some resources we use for animations. We use, most of these are obviously available on the official Flutter docs. And we were supposed to talk about staggered. Tomiwa, do you want to talk about that? Yeah.
Okay. I don't know. Maybe we have time.
Fine.
But we are supposed to talk about staggered animations, but we just give an overview of staggered animation. So, as the name implies, staggered. So, staggered animation is an animation we use when we want to animate multiple things on a page. In the sense that maybe if you, at least a lot of us have used Instagram, yeah? So if you look at the Instagram search page where we have multiple grid view, maybe you want to animate each grid view when they show. Maybe when you enter that page, you want to animate all the grid view in that page, and you want them to follow each other. Maybe you want the first grid view to show, then the second one, the third one follows the first one. So yeah. So that's what staggered animation, what staggered animation do for us. But you can check the official Flutter docs. They are perfect examples of staggered animations. So Q&A section. So far, we have been talking about animation. We have been talking about curves, explicit, implicit animation, heroes, and all. So I know you have something in your mind that you want to tell us. So
yeah.
This is the time. All right.
It's over.
Nobody have questions? Why?
Maybe I asked. Okay.
Okay.
Any questions for them before we round off? Okay, how many questions do we have? Please, if we have questions, raise up your hands. Just raise up your hands so I can count. 1, 2. I thought you had your hands up. You're not asking again. 3. All right. 1, 2, 3. Okay, so let's start from.
So thank you for this speech. My question is, can you give us your thought process on how you implement complex animations?
That's interesting. Yeah, let me take that. Okay. Usually when I want to animate any property of any widget or whatever, my focus is on what is changing. So based on what is changing, I can be able to tell what widget or what widget, I'll ask myself, what does Flutter provide for me that can help me? If, for example, I see a box moving from one place to another, I ask myself, what is changing? So if the box is moving from one place to another, obviously position is changing. Now I ask myself, what does Flutter offers me to move items from one position to another smoothly? of course, the first thing that will come to my mind is an implicit. So I'll ask myself, is there any implicit widget, an implicit foo that helps me to move a widget from one point to another smoothly? If I don't find one, then I think, can I use an animation builder, the twin animation builder, where I'm going to set my own properties, what I'm translating from, while I'm moving from to the next. Now, if animation full can solve that problem for me, and twin animation builder can solve that for me, then I have what I'm looking for. Now, I ask myself another question: does the animation requires a lot of control? It's different if I have to animate a value from 1 to 0, and it's different if I have to animate it from 1 to 0 and wait for some seconds before moving it to the next point. There, I'm going to talk about explicit. Thank you.
All right, thank you very much. So, I think we have two more questions to go, but it's already time for the next breakout session. So, what I would say is, for those that have questions, please during the networking session, just approach them, ask their questions, and I'm sure they'll be glad to answer. Thank you very much. A round of applause for them, please. A very big, loud round of applause for them. Please keep clapping for them as they come down the stage. All right, so okay, so quickly we're going to go into the next breakout session, and we have three breakout topics. The first one is building a watch party with Flutter, and that is going to be hosted by Ijeoma Ogbonna and Deborah Kolawole in the Nairobi Hall. So that's the Eco Arena, now Nairobi Hall. That's the first hall. Then the second one, hosting here, is securing Flutter apps, how I can hack yours and how you can stop me by Rexford is going to happen in this hall. Then the third one is designing offline first Flutter apps for performance and reliability. That is happening downstairs. So please, 5 minutes to quickly go to your hall. I think we have people for this session coming here already. So again, out. Is out. Yes. All right. So again, building a watch party app with Flutter, Ijeoma Ogbonna and Deborah Kolawole, Nairobi Hall, happening at the Nairobi Hall. Securing Flutter apps, how I can hack yours and how you can stop me, happening here by Rex. Designing offline first Flutter apps for performance and reliability, happening downstairs at the Cairo Hall. Should I say that again? What's going on? Technical. All right, let's do that quickly, please. You're here for securing. We have another 30 minutes for this session. So, quickly, please put your hands together to welcome Rexford as Salma. Did I get it? I'm sorry. Okay, he's a Flutter engineer and he will be talking on securing Flutter apps and how I can hack yours and how you can stop it. Thank you. A round of applause for him. Sorry, please, before you start. A round of applause for him. Okay, thank you.
$224 apps, and it was very and then it's an issue because why? And they concluded their research with the fact that about 95% of apps in Africa is easy to be exploited. And then they also noticed that with that same apps that they did a test on, it has a massive amount of users, and then is at higher risk. So this is not like a medium risk, a higher risk, which means that it's something that we need to care more about. Because if your user is using your app and then they notice the next day their data, their login information, their password is outside, which is actually possible, which I could have shown you guys, but my laptop is not here. You could see how you can decompile and then do some transpiling and you can get people's information. Yeah, so about that. So how do I go about trying to hack people? So we have something called jailbreaks. So I know it's an African stuff where you buy the phone and you say that, oh my guy, I want to be able to use certain things that iOS does not permit me to use. So you would intentionally, on Android, we call it rooting. You will root your phone so that you would bypass some manufacturing rules, and then you will just install your app, right? We mostly use that. I think around 2019, I was fan of one game. I want more coins, so I rooted my phone, and I'll be able to bypass the coin side and be able to buy more coin without even paying a damn. So we take that for granted. We just buy phone, it's jailbroken, and we just use it because we feel like we have more features within our manufacturing just to use it. But that is a problem for which, to me, is an opportunity, because jailbreaking actually means that iOS has a very high security systems. So as far as you jailbreak it, what it means to me is I have access to things without iOS restricting me. So I can write my malicious codes, I put it inside a mobile app, I send it, and then you have it installed on your phone. I don't have the manufacturing complaining about it to you because you have jailbroken your phone. So the manufacturer does not have access to certain features that they can say, hey, this app is high a lot of viruses on this or blah. So you just don't see, and you just install that. So that is an advantage for me. Another thing is something we call overlay attack. We mostly download apps. I can't remember, you just download, nowadays on Android devices, you can download a translator and it can read your screen. And we are a fan of it. We just go and then we download all the translators are available because we want it to be able to read our screen, convert the text in there, and be able to like translate the language for us. So overlay attack, what happens is that the moment you allow me to be able to do that, we have APIs that allow me, the developer, to be able to access certain functionalities that you don't know. So I'll talk about some funny stuff. It's called Godfather. It was a hacking this thing that was rising up. So Godfather, what happened was that they were using an overlay. They published an app to Play Store, and then the app was a scan app. So it tells you that it's just scanning something. So give me an access to your overlay. And then you just agree to the permission. And then what they do is that whenever you are trying to type something, they overlay something on it. So just like your mobile app screen, exactly like that. They will give you an input field. And then you will type your inputs and then you will send it. And then they get access to those information. So that's an overlay attack. And then one question I was asking myself that, is it really serious? And I noticed this is just crazy because I can ask for any permission I have. One thing about Android and not iOS is that Android sometimes may bypass not asking for permission, especially the older Android versions. But the current Android version are even asking for notification permission. But the older Android version will not ask for any notification permission. It just starts using the permission access. So this is a very serious issue because if I'm able to install that app on your phone and then I can't ask for any permission, I have access to accessing your microphone, for which, if you guys have realized, if you pick your Android device and you start talking about, I want to kill this cat, I want to kill this cat, all of a sudden you go to TikTok and then you start seeing cats. Why? Because they have permission. Why? Because they have permission they have access to your microphone. They have access to your SMS. I'll tell you guys a very serious thing about SMS and how we are doing it. But just to move back, we also have reverse engineering, which is the most popular guy, is the big deal out there. And then what is reverse engineering? It's very simple. It's trying to get the original form of what you have compiled as a very nice APK. So whenever you compile your app, it's a very nice APK that you send to people to install, or an iPack that you send to people to install on their device. So reverse engineering means that I am trying to pick that APK names to make it harder for me from accessing certain things. So maybe I should have taken 2 minutes to be able to put back your code together. Now it's taking me 10 hours, but it doesn't mean I can't do it. If I'm ready to hack your app, I can do that. So Flutter makes it very clear. This is part of their documentation. I'm not making it up. It says that it is a poor security practice to say that you are obfuscating code to make it secure. It's a poor security practice. Like you said, oh, I'm trying to obfuscate code and I will make it better. Nobody can hack my app. It's a poor security practice that you don't want to do. And it's part of the documentation. You can actually go and check. And then one thing about that obfuscation is that it's a low-level version. What it does is that it doesn't do anything. What it does is that it just pick your variables and then just do some rambling around it and then just generate some crazy text and then make it work like that. So I won't advise. So I'm saying that when I'm doing reverse engineering, what am I doing? Mostly, I'm trying to understand your system to see how your system works. So mostly reverse engineering, I may not be necessary to be putting back your code together, by trying to understand your system to see that, oh, this is a crypto system. This is how it goes. This is where it passes. This is what I can do to pass through. So we have something called debug attacking. What I do is that I'm able to debug your course, HTTP course. And then I'm able to see that by using your HTTP course, maybe I'm trying to log in. And I know that by doing debug attack, I know that, oh, trying to log in, this is how you do your login. So I would attach something to, like, based on how you do your login, I would try to exploit your code and see that, how do you pass your credentials? How is it being done? And then I would just find a way to, like, do it through the debug attacking. So I get your endpoint, and I will just emulate your code a bit, and then I will just hack it. Another thing is that do your system is to repackage it. So you see WhatsApp mode. It's not like someone sat down to write the whole WhatsApp app. So you see GB WhatsApp. It's not like they sat down to write the whole GB WhatsApp. It's reverse engineering. They reverse the code and then try to make sense of it and recompile the app. So it has happened before. A very popular app in Europe, it was repackaged and published to Play Store, and it got over 2 million downloads, and then they were on a hot kick because everyone money was just disappearing from their accounts because they thought that was the original app, but now it's the fake version. So it's a very serious thing that you don't want to talk about. So how can you stop me? First one, from the jailbreaks, and then to avoid me, you have to avoid jailbreaks app from accessing your stuff. I was going to show you something about security stuff that you can check if your app jailbreak is a serious thing. But as I said, not every app needs to avoid from accessing from jailbreaks app, mobile phones accessing your app. So not every app. Some apps you don't need them. But most apps, especially what I'm keen about is fintech app, your crypto apps, your whatever apps, you need to avoid jailbreaks phone to access it. So if the people are serious about your app, they should go and get a good phone that is not jailbroken and to access your app, because it's very easy for people to get into it when they are using jailbreaks app. Just this thing, quick one for you. It's very easy to set up these things in Flutter. So this one is a package, and then it allows you to avoid jailbreaks and roots in Flutter. It's just very simple. This is just 3 lines of code, and then you have it. Another thing is how to stop overlay attack. So this UI that you guys are seeing right now is an overlay attack, and it says that please confirm that you have agreed the terms and conditions, and then you just click OK. You know, because it's overlay attack. You don't know. You know that you think it's a phone feature, so you just click OK. But someone has tried to access your phone and overlay this thing on top of it. As soon as you click on OK, you just notice that something is going on in your phone, and then you are just not making it. So I'm saying that with this overlay stuff, it mostly does not happen on iOS if you are not using a jailbreak phone on iOS. iOS people can mostly avoid it because iOS does not allow you to overlay stuff on the device, but Android is the issue. But for us, for the Android users, the Android community people are trying to do something for us to avoid it. So now you see that they have APIs to be able to avoid people overlaying on your app. So one example is WhatsApp. WhatsApp, you cannot overlay. And another, yes, WhatsApp profile picture now. I'm a beta user for WhatsApp. So if I'm saying something that doesn't make sense, beta user means that I get first access to WhatsApp. So WhatsApp is working on a feature. You cannot screenshot anything. You cannot screenshot anything, right? And then they are working on a team stuff that avoids you to do avoid certain stuff about overlays. So it's a new feature Android has added that you can add it to your app, your manifest, and then everything is voila, you are set to go. Last one that I'll talk about, and I'll give you my bonuses for my company, what we do at my company, and then I'm done for the day. And then maybe you will not meet me again because I'm going back to my country. Yeah. So we call this SLL pinning. What does it do? So this guy allows only things, only endpoints with your certificate to be able to access your backend APIs or backend endpoints, right? So when you do this in your Flutter app, it allows you to block people without that certificate to access those endpoints. So anyone without a certificate, Flutter would return that you have an invalid certificate to access this endpoint. So it is very important. Most people doesn't do it, but now mostly on the web, that you see that they have some padlock over there as part of the browser. It's part of certificate SSL. So in mobile app too, we have that, but this time we add it mostly to our HTTP course, so that you add a certificate, so it validates the certificate. But it's very complicated though, because the certificate, what it happens is that it's kind of become invalid. You need to upload it again and all kind of stuff, but I think that works. And then my last part, and then I will end here, is my bonuses, which is very important. I want to add this, and even if they say I should go, I will not go because I want to talk about these things. Yeah, it's just 3 things. We call something Sandburst. And then this is the first thing we started doing in our company. And it's about trying to store, so we mostly store user information on the device, right? That is what Flutter, we are used to, Flutter Secure Storage or Flutter Storage. We store device information. But this is called Sandburst. What it does is that I'm storing the information on the device, but it comes with a password. The information is first encrypted, but it still comes with a password. So you have to have the password first, and then you encrypt the information. So getting the password is not easy because the password is not like anywhere, it's something from us, right? And it's generated from the backend. And so it's hard. You have to hack my backend first, hack the mobile app before you get the password, and we have an encrypted message for you. Another thing is you validate your app against the OPS checklist, which is also there. It's a long checklist that allows you to check for security. If I was having my laptop, I would have showed you guys very quick. They have a platform that you can just upload your app, and then it tells you what is it meeting and what is not meeting. The last one is a very important thing that you have to take from me right now is that stop using SMS OTPs. It's very deadly. SMS OTPs is very deadly. You should actually opt in for Authenticator because SMS OTP, what it does is that I can only buy to your network tunnel, right? And then I can say that I'm trying to impersonate you. I'm you. So whenever I send SMS, it doesn't come to your phone. It will come to my phone. And it's very easy. I should have talked about it, but it's an issue with the SS7 system, which the SMS use, right? The SS7 system is it has been an issue. They have been talking about it for over years. It's an issue. Everyone knows it. But we don't talk about it. We don't make noise about it. people feel like people don't really care more about it, but it's very deadly. So if you actually go home, you can search for SS7 attacks, and then you'll get to know more about it. Thank you. My name is Rexford, and I work at Bishop.
Thank you. I love that round of applause. Now I'm impressed. A round of applause for him, please. Another one. All right, so quickly, the third session has started, and I'm just going to go over it so you can go to your rooms. We have a session going on already. Flutter Fever, Catch the Testing Bug in Nairobi Hall by Oluwase Ajadi and JC Osile. Then bringing blockchain and Web3 into Flutter, happening here by Obum Nwambuede. Then AR on Maps by Kendi J in Cairo Hall downstairs. So quickly make it to your halls now.
Call his name. Call his name. Call his name. Open for here. I don't use. Let's mic him up.
All right. So again, please let's do this quietly. Again, Flutter Fever, Catch the Testing Bug by Oluwase Ajadi and JC Osile. Then Bringing Blockchain and Web3 into Flutter by Obum Nwambuede. Then the third one, AR on Maps by Ken DJ, happening downstairs in the Cairo Hall. Flutter Fever, Catching the Testing Bug, Oluwase Ajadi and JC Osile, Nairobi Hall. Bringing Blockchain and Web3 into Flutter, Obum Nwambuede, Cape Town Hall, yeah. Cape Town Hall, yeah. AR on Maps by Kendi J, downstairs, Cairo Hall. All right, so quickly, we're just going to move to the next session, and we're going to be Obum is a global developer expert. Obum is a Obum is a Google developer expert. Sorry, yeah, it's going global. Sorry, apologies. So again, Obum is a Google developer expert, GDE, in that and Flutter category. He has also worked as a mobile developer with Lockdown, Coders, Triangle, and VorbTech Innovative Solutions. He has also written several articles on Flutter in various publications, and he volunteers in tech communities. So guys, please join me to welcome Obum Nwambuede. Please, a round of applause for him, please. Okay, so. Okay.
So before we go to the next session, yes, he can't help.
Oh, this okay, right?
Doesn't matter.
Hello. 1, 2, 3, 2. 1, 2. One, two, two. 1, 2. 1, 2, 1, 2. 1, 2, 1, 2. 2, 2, 2. 1, 2. 2.
All right, thank you, everyone. Now, quickly, we're just going to move into the next session. And can we please jam our hands together for our next speaker, please? Thank you. Okay, so while we are waiting for our next speaker to come on stage, please move forward. Do we always have to say, I'll fight with two people? Move forward, please. Move forward. There's empty chairs in front of you. Forward.
Okay.
Please, let's quickly do that. Yeah, Obum, please come on stage. A round of applause for him, please.
Hi, everyone. Okay. Can you see it? Hi. Yeah, that works. Good afternoon, and welcome to this session. Yeah, bringing blockchain and Web3 into Flutter. Yeah, so blockchain. What we're going to do today, yeah, so here's the outline. We'll just touch a little of blockchain and look at it from the perspective of building decentralized applications. Hello? And we'll talk about blockchain from the perspective of, what's up now? From the perspective of building Flutter applications. So the blockchain is a massive, okay, before we have example Flutter Web3 apps about reading on-chain data, authentication, and smart contracts. That's it. Blockchain and Web3. If you know what blockchain does with, you know something about it from a developer perspective. Okay, thank you. So it's a big database. Data is stored and massively available, and it's all public. It uses a huge deal of cryptography, and it strives to come with decentralization and to make things a little different, to change the fact that, oh, your data is public, so you don't need to worry about privacy concerns. But then this data is cryptographically signed, so it's public and anonymous at the same time. Nobody can seem to track it to who is who. It's only when you like come out and say, this is my wallet address, that's when we know, oh, this is you. But aside that, all the activity you do with a particular wallet address, it's using it. Yeah. Now, Web3 is those set of tools that allow us to build on the chain. Yes. So with Web3, you talk about from Foundry, Forge. I think those are even the wrong examples. But I just mean the packages altogether that you can use to build, because our aim is to build decentralized applications. We are trying to complete the flow, because the blockchain allows you to I don't like the mic and discordance. You want to raise my voice? My voice is loud.
Hello. Is it working? I hope understanding that I should please wear this so I can enter the live stream.
Let me just, so guys, sorry, the mics are having the mics are streaming. Because we are live streaming, right? We need to wear the mic so that people that are watching on the live stream can also hear. But then that speakers might not, not transmitting to the speakers. It's the Nigerian program, what Nigerian says.
I'm trying to like bring us down from a developer perspective. Be aware that the blockchain ecosystem is all about data. Data is people will see the cryptocurrency data is a public database. I think this fundamental understanding is of where we're going. And there are many blockchains. Many blockchains came into the way. There are so many of them, like all of that, Cosmos, all the ecosystems. But as it is a work in progress. Blockchain is a work in progress. Blockchain is a work in progress. So you keep seeing new layer ones every day. New blockchains come and improve the flow. You understand? So not all of them, at least the very first versions, something like Bitcoin, you can't build on it. But from Ethereum and later to today, there is one way or the other to build on it. It becomes a de facto standard that when a new blockchain gets announced, they put out a section for developers, come and build on us, because aside from the money use case, it has become a norm that we can build on the chain. So instead of having your traditional backend or your traditional database, we are trying to leverage the database, the chain itself, the database. Yeah, it's kind of still a work in progress. There's still a lot of optimizations to do to it, from, in my own personal opinion, like looking from an advanced reason. If you try to build something like Facebook on any blockchain right now, it's very difficult. Things like gas fees and all of those, but a lot of engineers are working towards that. And so we don't want to be lagging behind. Because what's happening right now is that they are working on the chains to make it like better, but we also need the clients, developers that build client-facing apps to also get up to speed with these blockchain technologies to be capable of building against those chains as they're also building, because we now have many chains, but we don't have many apps meeting up the chains. So we need the advocacy of applications. Even if you start with just doing payments, or you progress to, aside from payments, start doing data, because data is what's more interesting. We want people to start having data on the chain. Yeah. So there are two facets of coding on crypto. So you're either coding the code that is run, you're either coding the code that is run inside the blockchain, or you're coding the code that is used to interact with the one in the blockchain. just the way you have front end and back end. Yeah, but the back end is what we call smart contracts. And I'm just giving an analogy, and whether it's on the web, like you're building on front-end JavaScript, or you're building on Android, iOS, or Flutter, your client side. So from here on, we'll be looking at blockchain coding from the client side. Yeah, so that works. And because it's Flutter, we'll be looking at I think this my example session is misleading. Example title, example Flutter Web3 apps is kind of misleading. Not really misleading. My aim is to tell us that we already have successful Flutter apps that are in Web3. Yeah, and how I knew was from this Flutter Shark. You know Flutter Shark, yeah. This is a screenshot of my phone, so I can confirm that these apps, Binance, Bybit, Trading, they were built with Flutter. I didn't even know. KuCoin, built with Flutter, Mexi, and maybe a lot. So these crypto systems are already tapping into our Flutter to serve both platforms, Android and iOS, and it works well. Like they have, Binance, Bybit have both their custodial wallets and the non-custodial wallets. Like I think the screenshots I put in for Binance is the non-custodial wallet. You see, they have the Web3 section. Yeah, they have this Web3 section, different from the exchange. So it's in the exchange part of these trading applications that you see their custodial wallets. Custodial wallets, like they keep the private keys. You don't know what's going on. Like you must log into your account to access it. But the non-custodial wallets, they can give you the private keys. They can give you the seed phrase. You can log it to in any other place. That's the difference. So they've used Flutter to build both custodial and non-custodial wallets. And these apps are written from the chain and are available as wallets, so you can build your own mobile apps to connect to wallets, which in turn people will use for authentication, which we'll look at next. So if big applications like Binance or Bybit, yes, they are trading apps, but if they could have built in Flutter, and we know they have massive downloads and usage and the delivering power, we have no excuse to not be capable of building any blockchain app on Flutter. And think about it, behind the scenes, the Flutter packages simply are doing HTTP calls to RPCs. RPCs, we know procedure calls, like they are nodes or intermediaries for the blockchain and for your HTTP calls. Because the blockchain is there and it's kind of siloed. It's like they're kind of within themselves and data is moving, network is moving. But then we have a lot of nodes out there, people who do mine and all of these things. They kind of keep that data available for us and kind of take our signed transactions. When it's signed, they bundle all of them and send to the chain for us. Like it's a full-blown ecosystem. But I think it's worth you knowing that the chain is there. It's actually everywhere on everybody's laptop. Like minus computer access. I'm trying to stress the S, like on billions is too much. Hundreds, thousands of various devices in different places. They're kind of having having the blockchain hosted there and leaving it publicly available. So they have auto signing or auto confirmations built in and all of those. And then we have these available RPCs that kind of index what's going on from the blockchain and make it available to us. So when normally you use most of the client packages, in reality you're talking to the RPC, which in turn talks to the blockchain. So they kind of make an HTTP call available for us. But in itself, the blockchain has to use those things. Like that's how it's built. So what are you reading to? That I started reading, and like I said, we either read or write. Write is like create, update, delete, but there is no delete. Everything's permanent. The delete is technical. Maybe when you're coding and you put data in an array somewhere and come back and you move that data, that's technically the delete. But aside from that, like changing data, writing to data, you need to sign a transaction. A private key is need to sign. Let us know which wallet is doing that. So that's where authentication comes in. But without that authentication or writing, reading data from the chain is massively available, and many things can be read from the chain. Yeah, things like balances, history of transactions, tokens, different things are readable. Any data, like every blockchain activity is readable programmatically. You just need to get to use the right packages, and I dare to say you also need a good amount of in-depth study of what's going on, like what is a token, what is a contract, or you need to like understand what's going on and understand how the engineering of these packages that we can use to read from the chain, like what it looks like. Like I said, smart contract is code that wrote within the blockchain. So in addition to reading already available blockchain data, chances are you will, not chances, most of the time you will be reading from smart contracts. You're reading data that maybe your own blockchain dev had already built in the smart contract, and that'll be that. Yeah. Take for example which blockchain example we use? Any the app you can think of, maybe a payments the app. So the app, maybe a raffle draw. So maybe the person has built a smart contract that can do raffle, people can connect and enter the raffle and all of those, and something like that. So you will be reading data from that particular smart contract about people who have entered raffles and displaying in Flutter, something like that. So reading data always comes first. You have to be very comfortable with reading, like seeing what's inside the chain. And I like saying that the Flutter is because of the community. The power of Flutter is because of the contributions of you and I. Yeah? Why? Because there are packages for this. We have different blockchain ecosystems. Stress on the word ecosystems or networks. Because a good number, F, Polygon, BNB, all of them, they use what we call the Ethereum virtual machine. Like, it has a different, you write in Solidity, how you consume it is different. We have Solana is kind of standalone, they're the only guys know what to do, but the smart contracts are written in Rust. And then we have Cosmos, a whole big level of ecosystem too, things like Noble, Gnosis, Benzion, Osmosis, and all of many of them. So those have a different rules guiding how you read and write from them or how you store data in them. In turn, one of the advocates is that you can start building multi-chain apps, applications that are available from either of any chain. Users don't need to know that there are multiple chains. We're trying to start advocating for chain abstraction. It's a common terminology in the Web3 space right now. So that is why I was like, we should not only talk about Web3 that. If you go online and ask about Flutter blockchain, you'll be seeing mainly Solidity, F, because it's the most popular. But I think it's time, as we're talking about it, we're talking about all the ecosystems. There are more than this. Outside these three listed, there's SUI, SUI, yes, NIR. So they all have, okay, SUI, thank you. They all have like slightly different methods of reading from them. I don't know if they have the Flutter packages, but these are, I think, three most popular networks which when you handle, you've covered a good amount of blockchains. Yeah, so I tried just demoing how easy it is to read a balance. Yeah, you get a client, RPCR or something like that, and provide an address and read the balance. That's for EVM. But in Solana, yeah, something similar. Solana uses a base 58 cryptography. So they are running because of time. So I would have wanted to like explain more in details, but I decided to put just small code snippets. But I want to repeat the words of Jide Guru, and not GDE. His words were, when you're doing anything, know why and how you're doing it. Yeah, know why and how you're doing it. So I'd like you to, when you go back and you're doing Web3 in Flutter, understand why the choice of maybe a connection is used or client and stuff like that. Yeah. And now, that's about reading. So on the side of writing data for thank you.
Sorry, I know we're enjoying that, right? I'm sorry. I'm really sorry. All right, so how many more minutes? All right, so we're just going to, because other session has started, right, and we're going to have more people coming soon. So we are just going to go on for another 10 minutes. Is that fine? All right, thank you.
We had spoken about reading. Now it's time for writing. Like I said, blockchain data is public. Anybody can see anything. Likewise, the data is public and anybody can change it. But to change blockchain data, you need you need to sign a transaction. The keyword is signing. How we do authentication within the chain is that because there are no tokens, there are no JSON web tokens and all of those things. So it's a three-step thing, yeah? Public, private key, and data. I give my public key, I'm Obum, I give you Obum whatever. And there's a private key for Obum whatever. I take any data, maybe I take FlutterBytes, I use my private key and sign it, and I put the signature and I give you a signature. You take that signature and verify it against Obum. If it gives you my FlutterBytes, then you are sure Obum signed it without necessarily having Obum's private key. That is how authentication goes on in Web3. Like, this is how the cryptography is. We don't need to know, we don't need to have the key to open it, but we can verify that this key was used to sign this data. And that is about authentication. Where am I heading to? We cannot have access to private keys of users. It will mean like we're scanning them, like, you know, that's actually one good thing. Like with the Web3 blockchain stuff, you don't have it. But you connect to a wallet. In turn, the wallet will be used to, will have the private key of the user. When the user wants to make a transaction, you send the transaction to the wallet. The wallet will now call up to the user, authorize, and it goes through. Now, wallets are installed on mobile. They have different mobile apps, many of them, MetaMask, Quantum, and the list is long. But now, what we should be seeing is how do we connect to these wallets? Authentication. And authentication in Web3 serves two purposes. Apart from writing to the blockchain, the transactions, another advantage is your backend. We should just hint on little. Yeah. So that's for authentication. So there are many providers like Rion. It was formerly called Wallet Connect, but they've updated. They now called it Rion. Rion, I chose Rion because I just opinionatedly. I suppose maybe there are others in that sphere or circle, but it kind of keeps your connection alive between your DApp or smart contract, between your DApp or mobile app against their own RPC servers. They kind of keep it alive. So what they do is when you try to connect with Rion, right, Rion will call up installed mobile wallets. So the user can choose. When the user chooses, it will call back your app. Yeah, and then your app in turn can now, anytime you want to sign, you call back with the other packages I showed you, like the Web3 data and all of those things. This step is very important because to us mobile developers and Flutter especially, we need to do things with if it's on Android, around Android manifests. And the Android manifest, you need to define a scheme for your app so that the wallet can call you back. And Rion is expecting to see it like a redirection. I think that's one important thing. It's worth stressing that we get comfortable with. The fact that because we're in mobile and we're in Flutter across platform, you need to do this on Android and iOS. Define a custom scheme so that when your app has called up the wallet and the user has gone, by the time it's calling back, the operating system can call back your app and redirect into your app. If it was on the web, this might not be necessary because a browser extension will be used. But because we're on mobile and people love mobile, we just have to do the necessary requirements. There's even things about hosting deep link files that Android or iOS can use, things like that. But it's more important if you're building wallets. So this for iOS, you use bundle URL types and the info.plists file. Yeah. So to add Rion, you get a project ID, you create an account from them on Wallet Connect, and then cloud.reown.com, something like that, and you install the package or whatnot, just some normal Flutter things. You initialize the AppKit modal, provide necessary things. Because of time, I would have like given us more context about things I feel like you might not see in the docs, but let's just go on. And all of that. So the code you see currently is simple column, and then yeah, Flutter widgets are mouthful. AppKit modal select button, AppKit modal connect button, AppKit Nkenwa, all of them. But the idea is that they provide like widgets, which I won't even use their widgets, but I will use them. So they provided ways to authenticate, so you definitely have your own custom UI. But now this is what that UI looks like. Like the empty select wallets, but it's connected, it shows the balances. On the right, it's like the menu with installed wallets on your device. So if you tap on each one, it kind of goes for the redirection. Yeah. So writing. Before you can write, you need to authenticate. Once you have the smart contract, have the user authenticated with their wallet, to now authenticate or call smart contract calls, you have your contract address. And it also depends on which blockchain. Like the example here is like for EVM, you provide a lot of things. And I have to confess that for you to really understand what's going on, you might have to deepen yourself a little into how Web3 and the coding part of it works. But at least you're not overgo deep to understand the smart contract side of things. You just need to know that you have to understand the smart contracts data and understand how data works. Now that's where business logics come in. That's what's specific to business logic. But what I'm explaining cuts across no matter the app you're building. Yeah, you will need your the contract address of the smart contract, and then you need parameters, different things. This is the example in the doc. Yeah, but things like that. And there have been updates. The docs really help you here. So sometimes the blockchain does not fulfill everything. Yeah, talking about after I've written, sometimes you might need to like store some custom data yourself, or maybe you want to also make your DApp like close to experience. You're sending emails to your users after they've authenticated with another thing with the blockchain. There are some things you might want to do off chain yourself, and so when you need to know which of your users are authenticating, that signature stuff you can still do it here. You can request the user for a signature without necessarily sending a transaction, because when you send a transaction, they sign and it goes into the chain, and sometimes money will move and gas fees will be deducted. But you can request a signature that the user signs, maybe authentication or something like that. When they sign, it will give you back the result. You send that result, maybe it's not your token for the backend. When you decode it for what you expect, you now know the wallet address that interacted and you know what to do in your servers. I think it's worth mentioning, because people be like, oh, how do you do this other part of authentication? And it's the signatures take care of it. It's popular. Yeah. And sometimes if your data structures are really optimum, you might not necessarily have to do that. So I'm rounding up. This recommended practices, user experience, is kind of common knowledge, but I just felt like hinting it because the entire paradigm shift off from Web2 things, normal databases things, into what we have in Web3. Until we shift and we stress ourselves to code, we forget to still make the app the best. Don't forget to use good UIs, yeah, and when you're fetching data, reading data, paginate, because if you go and try to read everything at once, it will not go through. The RPC will fail because of gas. But if you try to read one after the other, the user will have a longer wait time. So it's okay to like paginate maybe 10 or 20 in batches, depending on what the app you're building. But in most cases, you always show data. Because the beauty of all apps you build is the user data we are showing them. So you need to wait to like, after saying, okay, this is how we'll show it. The data itself, you arrange it a lot. Yeah. Use nice skeleton loaders. Tell the user what's going on. Oh, we are finalizing the transaction, we are signing. And then you can listen to smart contract events. Smart contracts have events, so you can listen and then know when to refresh your page. Like if things have changed, like to really give a reactive view and maybe notify users when things are necessary. For a recap, yeah, we've looked at building blockchain, bringing blockchain to Flutter. There's a lot more, but I try to give a high level yet detailed overview that it's about reading and writing, reading user necessary packages, right? So you connect with providers like Roam, and sometimes you might build your own wallet. You can build your own wallet in Flutter. Roam supports that, but it's all about Roam that I suppose there are other providers. Yeah, I think Web3 off does something similar, but then they use they also provide you with social logins, email, Google, whatever. Even Rain does that. But I think we need a provider for that. Except you want to build yours yourself. Like, I would like to join the project. We need more open source. I mean, it's open source, so no big deal. And we looked at writing data and best practices. So that was the end of my session. Thanks for joining me here.
Can you smile better, like brighter now? Are we fine? All right, another round of applause for him, please. So, okay, pictures. Yeah. So I would like to move closer. We don't have like so much time, so quickly, if you'd like to take a picture with him, please come aboard. Sorry, another round of applause for him, please. So quickly, we're going to go to the next breakout session. We have some going up, the workshop going up already. So the first one is state restoration, making the dead states live again. And that is by Samuel Adaba, already happening at the Nairobi Hall. That's the first hall. The second one is FFI, the right way, delivering messages with Pigeon, happening downstairs. Then the one happening here is decoding that, an in-depth look at that VM by Festus Olusegun, happening here. So again, state restoration, making the dead states live again. Samuel Adaba, the main hall. Then FFI, the right way, delivering messages with pigeons, Ode, happening downstairs. Then decoding that, an in-depth look at that VM, happening here. So let's quickly move and start this session. If you are staying in this hall, please move closer. Make sure there are no empty seats in front of you. Can we do that quickly, please? Okay. State restoration, making the dead states live again. Samuel Adaba, the main org. Then FFI, the right way, delivering messages with pigeon. Sebastian Ode, happening downstairs. Then decoding that, an in-depth look at that VM, happening here by Festus Olusegun. So are we good now? All right, thank you. So please join me to welcome our speaker today. Festus Olusegun is a mobile and back-end developer who has spent most of his time working with Flutter. He's also a Google developer expert for Flutter and that. He gives back to the community by contributing to open source projects and mentoring developers. During his free time, he likes watching movies, traveling, and playing video games. So please, join your hands together to welcome Festus Olusegun to the stage. Please. What's going on? Stop. So now, put your hands together to welcome Festus Olusegun. Hey. Thank you.
Hello guys, yeah, sorry for the delay. So we're trying to set up the slides on the screen.
Probably have to, are you coding? Are you doing like coding?
This, but listen, I must. Hello guys. I'm only hearing one person saying I. Hello, guys. All right. So thanks for coming to this talk. My name is Festus Babajide Olusegun, and I'll be speaking on decoding darts, an in-depth look at the Dart VM. So, a little about myself. I am a software engineer. I have been building Flutter apps for over 6 years now. Also, I consider myself a content creator. I do YouTube tutorials on Flutter. I also share my knowledge on Twitter and GitHub. And last but not the least, I'm a GDE for Flutter and Dart. Thank you. So, why this topic, you might be asking. So, I started Flutter over 6 years ago, as I said before, and coming from a native background, building native apps, or native Android apps, I've always had this pain point around Gradle, and also there's no hot reload. There was no hot reload, at least. I don't know about now. So whenever you make changes, you have to basically restart the app from scratch. And first time I used Flutter, one of the things that really stood out to me, that compelled me to to the framework, to continue using the framework, was this hot reload thing. And one day I was just sitting down, I was asking myself this question: why does hot reload work on Flutter and not, on native like Kotlin? And that's like a question that made me go down this rabbit hole of doing research around why hot reload works and why not. So the secret to why it works is in the Dart VM, and that's why I'll be talking about Dart VM today. Okay, so let's start by understanding the fact that immediately you press the run button. So let's say you have your code, your Flutter code, and you press the run button. Magically, the Flutter app appears. But what actually happens under the hood, right? So when you press the run button, first thing that happens is the source code goes to the compiler, and this compiler has two parts. Just like our mobile application and web application, we have backend and front end, right? The compiler also has a backend and a front end. And the front end is usually responsible for passing the code, tokenization, passing the code, and translating that code into intermediate representation. So this is like bytecode. Basically, when you run your app, it goes from Dart to IR, then machine code. The machine code is what your device is going to understand, like your mobile phone, your mobile phone, your Android phone, your iOS phone, and whatever. So after the passing, you get the intermediate representation, which then goes to the backend of the compiler. The backend, in the case of Dart, is a Dart VM, which is what we'll be speaking about today. So the backend, which is the Dart VM, has certain components like the JIT AOT compiler, because your code goes from compilation to execution, and to maybe to the time the app dies. So the compiler is JIT and AOT compiler. We'll be talking about this compilers in full very soon. Then the execution, which is the runtime system of Dart, and then the garbage collector. So let's kind of dive in a little bit. So this is just a basic comparison with of the Dart VM with JVM and V8. So the JVM is the Java virtual machine, and the V8 is the JavaScript engine. So we have very limited time, so I won't be going through everything one by one. So when we're talking about the Dart virtual machine, the Dart VM, there are a few things that comes to mind. First would be compilation. Compilation happens there are two methods: the JIT compiler and the AOT compiler. Then after compilation, you're talking about execution, the runtime, which is the Dart runtime, and we have garbage collector, which is for memory optimization, and finally we have memory management, not memory optimization. Finally, we have optimization and profiling, which is profiling is done with like DevTools. I'm not sure if you're familiar with DevTools. So let's start with compilation. first we have the JIT compiler. So what's the JIT compiler? JIT stands for just in time, meaning your code is being compiled exactly when you need it. So what happens is the source code goes to the front end, as usual, for tokenization, parsing, and all that. So the IR, which is the intermediate representation or bytecode, goes to the JIT compiler. So this JIT compiler compiles part of your code as you need it. So instead of compiling all your code, your application, to machine code at once and running it, it compiles it bit by bit as you need it. And this is exactly why hot reload is possible in Dart. That's why when you make a simple change, you can press the hot reload button and the code gets pushed into your app and gets compiled right there. That's why this hot reload is very possible. So that's JIT. JIT is used mostly in development environments. So you are developing, you need rapid feedback. As you're developing, you want to see that the button of the color of your button change. You want to see the animation is working. So this is where this JIT compiler comes in. And next, we have the AOT compiler. So the AOT compiler is a little different. So AOT stands for ahead of time. So ahead of time meaning your code is compiled at once into machine code. It's not like JIT that compiles when you need it. I'm not sure if that makes sense. So the code goes through the front end, just like the JIT compiler. Your code has to go to the front end of the compiler before getting to the Dart VM, which is the back end. And when it gets to the AOT compiler, the AOT compiler compiles the entire code base. The JIT compiler compiles bit by bit as you need it, right? But the AOT compiler, on the other hand, just basically compiles everything, all the code, at once to machine code. So, and apart from compiling your entire code base, it also does some aggressive optimization, because AOT is used in production environments where you need, you need a performance, right? You need performance, so the optimization needs to be done. And JIT, since it compiles your code progressively, it's not as performant as AOT. That's why JIT is used in development and AOT is used in production. So after compiling your code, it goes to machine code, which is what your device can actually understand and execute. So here we have some recap of AOT and JIT. So JIT is at runtime while your application is executing. AOT is ahead of time. Basically, when you run that Flutter build APK command, everything is compiled at once, and you get your APK. And there are some other things here, but we can't go through all of them since the time is quite limited. So the next thing we'll be talking about is the runtime system. And when we're talking about the Dart runtime, there are a few things that comes to mind. First is concurrency. Second would be object model. And the third one is garbage collector. So we're going to try to touch all these three things. And we start with object model. So the object model in Dart, I'm guessing everyone here is a Flutter developer. You're a Flutter developer, raise up your hand. So in Flutter, you must have heard this thing, everything is a widget. But when you start writing Flutter, you notice that not everything is actually a widget. The reason is because of Dart. Because in Dart, everything is an object. So Flutter, everything is a widget. Dart, everything is an object. So the Dart is responsible for the logic, right? So you have to deal with the object, creating your variables, creating your classes, your data models, and all that. Everything, all those things are objects. So all values, like I just said, your numbers, your strings, your functions, even null, everything is an object in Dart. And classes, your classes also are objects. Classes is a blueprint for creating an object. And an object is an instance of a class. Then the root class. So every object in Dart basically directly inherits this root class, the object class. So that's why almost every object you see in Dart has this toString and has this equal to and this hash code. That is why everything is an object, and all the objects, they all inherit things from the object class, the object class itself, which is the root object class. Now we can go towards concurrency and event loop. Okay, so what is concurrency? Can anyone volunteer to just explain to the best of their knowledge what concurrency is? Anyone? Okay. Well, don't worry, I'll explain. So concurrency is basically the ability to perform multiple overlapping tasks at once without blocking each other. So imagine Lagos, for example. We have Downfall, the bus, and inside your Downfall you have your driver. You have your driver, you have the conductor. This driver is focused on driving the bus, basically avoiding all the mad Lagos drivers, avoiding accidents, avoiding potholes and things like that. And the conductor is more focused on shouting Ojo Elegba, and trying to get passengers into the bus and also getting them out. So these two people are doing their job concurrently without blocking each other. Imagine if there was no conductor in the bus. I'm not sure if you've seen that before. I'm guessing maybe it's kind of common in some places. So if there's no conductor in the bus, the driver will have to do the jobs of this conductor, and that will make things a bit more, the journey will probably get longer because the conductor is shortening the time. And that's why concurrency is important, because in every mobile application, there is concurrency. You tap your button, there's a set state happening, the text is updating, you are getting data from the API. All these things are happening at once. They are all concurrency. They are happening concurrently, sorry. So a practical example would be a mobile application, let's say a messaging app, and this messaging app has a button and a text input, right? And someone sends you an image. So you press this image to start downloading the image, like WhatsApp, for example. While this image is downloading, you can still be texting that person at the same time. Imagine you have to wait for the image to finish downloading before you can text the person. That will make life a living hell. It will make everything slow. Everything you want to do will take way more time than needed. So yeah, the image is downloading, you send a text, everything goes at once. All that is concurrency. So concurrency happens every day of our lives. So types of concurrency in Flutter and Dart. We have asynchronous programming, and there are two types of asynchronous programming. There are two methods, sorry. We have future and we have streams. So I'm guessing we know what futures and streams are, so I don't have to go into explaining all that. So future is like a value that's not currently available, that will be available later in the future, something like that. And streams is, a bunch of values coming in at all times. And we have multi-threading. So in multi-threading in Dart, what we can use is isolates. So let's talk about isolates. Everyone already knows what futures and streams are, so let's talk about isolates. So Dart, the Dart programming language, is single-threaded, meaning everything you are doing, everything in the app is happening in just one thread. This thread has limited memory, so sometimes the app can start lagging. It's something that will happen. So this is the main thread. I'm not sure. Okay, this is the main thread. The main isolate, we call them isolates in Flutter, no thread. The main isolate is responsible for painting, doing everything you want to do. Like the example I had before with the messaging app, you press the download button, right? The main isolate is responsible for downloading that image, also sending the text, all these things at once. And the truth is that when you have a lot of things happening at once, it can slow down, it can eat a lot of your memory, and then the app will start slowing down. I'm sure a lot of us have experienced that when you have your Flutter app and it's just very, very slow, and you can't understand, why is this thing so slow? What is happening? Yeah. So in isolates, so what you can do in that kind of situation is, let's say you have a big image to download, like the chat app I just used as an example. Rather than downloading it in the main isolate, you can always spawn a new isolate, right? And when you spawn a new isolate, this isolate, you can call it download task isolate, and this isolate will have its own memory. So it won't be using the memory that the main isolate is using. It has its own memory, and it can perform the tasks with that memory. It doesn't have to tap into the one that the main isolate is using. And this is going to make your app a bit faster. So you spawn a new isolate, you send the download link to the isolate, you download the file. Once the download is complete, you exit the isolate, and then you send the file back to the main isolate. So that is the flow of isolates. So isolates, they don't share memory, they don't share anything. So the only way for them to communicate is through sending messages. You want to download the file, you send the link of the file as a message to the isolate. Once it's done, you send that file back, something like that, as messages. So, sorry, I forgot to say, each isolate has an event loop, and the event loop is responsible for, actually I can just explain the event loop in the next slide. So imagine you have, your app has a timeline. You open your app now, and in a few minutes, you close it. That's like the timeline. But in the middle of, in the span of that few minutes, a lot of things are happening. And so I represent these things as this shape you see here. For example, it could be you are certain states, that's repaint. You are downloading the file, you are sending the message, you are getting you are getting JSON from the API. All these things are events, right? So all these events, they are on an event queue. They're on an event queue, right? So what happens? What the event loop does is it comes to the event queue and takes the most recent event, and then it executes it. Once that's done, it goes back, takes the next one, it executes it, and then till all the events are done. That's basically how the event loop works. So this is what helps your application run. These are the things that are happening under the hood. When you run the application, when you build the application and you put it out there, certain things are happening. And understanding them can help you, make the performance better and all those things. So, for example, now we have this code. It's a button, right? The button, when you tap the button, we're getting a JSON, we're getting response from an API, and then we're just printing success. All these things are events. The on-press is an event. The future, once the result is back, the callback, the then callback is an event. You are waiting for the response to come back. So everything is an event. And apart from the event queue, we have the microtask queue. So these microtasks, they are more like, how do I put it? So this microtask, they are more like things you want to happen before an event happens. So I'm not sure the kind of example to use, but let's say you want to download a file, but before downloading the file, there's something you want to do. This kind of thing you can put in a microtask queue, because the microtask queue has priority over the event queue. The way the event loop handles the queues are, it goes through the microtask queue. It basically runs everything in the microtask queue before then going to the event queue. So the microtask queue has the priority. And I'll be thinking, how can I create a microtask? So there is a function, a callback called schedule microtask. So if you see this code, you see first we have a future. The future is printing event task future. Then we have a microtask printing microtask, and then we have a synchronous print that says sync task. When you run this code, you know that the future comes first in the code, but the future will be the last thing to print because you have to wait for a few seconds before the thing comes. So the first thing that will happen will be the synchronous events, right? That will be the first thing to get executed. Then the microtask, even though the microtask is below the future in the code, is going to come next after the synchronous events, then the future. So understanding these kind of things, these little things, can help you make better decisions when building mobile apps. And then we have memory management. So we have garbage collection for memory management in Flutter. So it might be garbage collection, like the name says, it basically collects garbage. I don't know, I think they call them loma here, people that come and carry garbage. So it's kind of like that. So now you might be thinking, what is garbage in the context of my application? The garbage collector is generational. It has 2 generations. And yeah, so kind of this man, you take the garbage out. 2 generations, there's the young generation collection, that's done by the young space scavenger, and then the old generation collection done by the parallel max sweep. So there are 2 generations. The young generation, which is something like this. So here, the young generations are they're called short-lived objects. So let's say you are making an API call. In your API call, you get a response. Right? After that response, you use that response to display something on your screen. You don't need that response anymore. The response is the response variable. You don't need it anymore. So what happens? That response was created and assigned in memory. When you created that variable, there was a memory assigned to it. So when you finish using it, what happens to it? It's not going to just stay there. Right? If it stays there, that memory is not going to get freed up. So what happens is the garbage collector comes in and picks it up and disposes of it. That way you get that memory back and you can use it for something else. So that's the short-lived objects. And then we have the long-lived objects. So long-lived objects are more like, things that are going to span the rest of for the entire lifespan of your app, entire life cycle of your app. Let's say you have a class that manages your app theme. You have your dark mode, you have your light mode. There's a particular qubit or block or provider that manages that particular variable. That thing is going to be there from the time you open your app till the time you close it, right? And that one is a long-lived object. So what happens? That one is not immediately. It doesn't get disposed immediately. It's going to stay in memory till you close your app, right? And also we have some. I didn't add this one to the slide, but I'm going to try and explain anyways. We have some variables. We have some classes. Some objects that doesn't get automatically disposed. So things like your scroll controllers, your value notifiers, animation controllers, all these things. You might have noticed that once you finish them, there's a dispose method in your widget that you have to call animation controller.dispose. The reason for that is because the garbage collector cannot automatically dispose these particular classes, these objects. So you have to dispose them yourself. And failure to do so will be very, very bad for your application, because when you have a bunch of controllers and you don't dispose them, they will stay in memory. They'll keep using the memory of your application. And since that memory is not free, the more you keep creating variables, before you know it, your app will start lagging. That's why you always have to try to dispose your controllers. So, optimization. So that VM has some methods for optimizing our code. The function inlining, dead code elimination, and constant folding. So this is an example of function inlining. So you have a function, and before your inlining, you have int result, and you call the function. So what the optimizer is going to do is, instead of referencing that function, it just basically adds the code there. That way, it kind of frees up some memory. And we have dead code elimination. So in this calculate function, we have this if false. This if false is never going to get executed, because false is going to be false. So what the optimizer is going to do is kind of just clear out that code, because it's not used. And the constant folding, you have a constant 10 times 20. I don't even know why anyone would code like this. You should just have 200 at once. So if you have something like this, the compiler will just automatically, fold it and change it to like 200 for you. So conclusions, basically. That VM in Flutter, that VM is the core of how our Flutter application runs. Without that VM, yeah, your app will not run. Basically, that's just what this means. And that VM provides features like the JIT during development for auto reload, and the AOT, like we've discussed before, for optimized performance in production. And it manages code execution, memory, performance optimization for smooth UI, smooth and responsive UI. Then we have that VM on the web. Well, there is no that VM on the web. That's just the truth, because Dart compiles to JavaScript or WASM directly without the need for the Dart VM. So, yeah, that's all the conclusions. So, thank you very much for listening. If you have any questions, please, I can take like 2 questions. Yeah.
All right, any questions for him? If you have questions, please raise up your hand so we can count. Okay, I think we just have one person.
Yeah, good day, everyone. So I wanted to ask concerning garbage collection, because you talked about the young generation and the old generation. So I wanted to ask, is there a way you could choose which one you want to keep? Because I had the understanding that variables are just variables. Even if you instantiate a class, it might not be used often. But a variable now, you could use it even throughout the life cycle. So I wanted to ask, is there a way to distinguish by yourself when you want it to last long or not?
Okay, yeah, so the Dart VM automatically does this. Basically, it goes through, there are 2 algorithms that the garbage collector uses, the young space scavenger and the parallel max sweep. So what happens is the Dart VM, the garbage collector, it goes through your code. It will check variables, check if these variables are going to be short-lived. Then it knows that, okay, this variable is going to be short-lived, so I have to come back for it ASAP to clean it up. But if not, it promotes it to old generation, which is going to be like, okay, I'll come back and clean this up later on. So how do you know which one is going to be young generation or old generation? I think it depends on the way you write your code. If you have classes, objects that that are going to last throughout the lifetime of your app, like I said, something like a qubit or a notifier for changing your app theme, that one is going to last for the entire app life cycle. Your user session classes, if you have something like that, is going to last for the entire app life cycle. With something like maybe a variable that you created in a page, create a variable in a page, maybe it's loading. That is loading variable that you have in your pages. That one, for example, is going to be short-lived because that page is not going to be not going to be there for the entire life cycle. Once you close that page, everything there is gone. That one is short-lived. I hope that answers your question.
Thank you. Thank you very much. Sorry, another round of applause for him, please. Do we need to take pictures? All right, pictures with Festus. If you would like to take pictures with him, please come on. All right, so thank you. So we have a group picture downstairs. Everybody, please, let's go downstairs.